In this lesson, you're going to learn how to ensure that the right people have the right access to the right resources within Linux. This will ensure that no one has more access than is necessary for them to do their job. Now, this is the process of configuring file and directory permissions, and that's what we're going to focus on here. Ideally, you'll begin restricting access to files and directories by applying proper permissions to those resources. Permissions are access rights that are going to be assigned to users, which enables them to access or modify certain files and directories. It can be set at different levels and for different access contexts as well. These access rights are going to enable you to configure who is allowed to access an object and who is restricted from accessing that object. Controlling access through permissions mitigates a lot of the risk you're going to have in a system, and it does this by ensuring that users are only able to access what they need to get their job done, and nothing additional. This is a security principle known as least privilege, and it is considered a best security practice. To see what permissions are set on a file or directory, you can use the ls command. Remember, the ls command is the list command. So if you type ls-l, this is going to give you a long list of all the files and directories in your current working directory. Each item in that list contains 7 columns, 3 of which display permission information. Column number 1 is going to identify if the item is a file or directory, the user, group, and other permission assigned, and the access method. Column number 2 refers to the number of links there are. Files generally only have a link count of 1. For directories, though, the link count is the number of directories underneath it plus 2. 1 for the directory itself, which is called the dot, and 1 for the parent directory, which is known as the dot dot. Links are similar to Windows shortcuts, and they point to the location where files exist and enable you to access and view the files. Column number 3 displays the owner of the file or directory. Column number 4 displays the group that has been granted access by the administrator. Column number 5 lists the size, in bytes, of the file or directory. Column number 6 displays the date and time that the file was created or last modified. And column number 7 displays the file or directory name. Permission attributes will define exactly what a user is allowed to do with a particular file or directory. These attributes behave differently based on whether they apply to a file or a directory. For files, the read permission, known as R, is going to enable the user to access and view the contents of the file. The write permission, or W, is going to enable the user to save changes to a file. And the execute permission, known as X, is going to enable the user to run a script, a program, or other software file. Now, if we're dealing with directories, on the other hand, the read permission, R, is going to enable the user to list the contents of that directory. The write permission, W, is going to enable the user to create, rename, or delete files within that directory. And the execute, or X permission, is going to enable the user to access a directory and execute a file from that directory or perform a task on that directory itself. Permission attributes on files and folders are applied to one of several contexts, or the different types of users and entities that you're going to give permission to. These contexts are the owner, known as U, the group, known as G, and other, known as O. The owner, or U, refers to the owner of the file or directory. This is also referred to as the user, which is why it's known as U. Now, these people are not going to impact the actions of any other users. They can only do things that affect themselves. When we move into G, or the group, this refers to the file or directory's group, and all the users who belong to that group can have those permissions. When we talk about O, or other, this refers to other users on the system, and these are users who are not the owner and they're not a group member. This is essentially the permission group that you need to watch the most when you're giving permissions and controlling least privilege. Now, the output of the ls-l command will show the permission string for a file or directory as you see the list of files. Now, the permission string here is going to contain 11 characters. The first character indicates the type of file. It has D for directory, or a hyphen or dash for file. Characters at the second, third, and fourth positions are going to denote the owner's permissions. The characters at the 5th, 6th, and 7th positions, they're going to denote your group permissions. The characters at the 8th, 9th, and 10th positions are going to denote the other permissions. The final character, that 11th position, is going to indicate the access method for the file. If you see a period, that's going to say there's a security context and a plus for any other combination of alternative access methods. The changemod command also can be used to enable you to modify the permissions of a file or directory. Only the owner of the file or directory or the system administrator, who is the root user, can change the permissions of that object. The proper way to enter the changemod command is by typing changemod your options, and then your mode, and then your file and directory name. The chmod command supports different options to modify permissions, which can be used at any time. If you use the -C option, you're going to be able to report changes that are made in permissions. If you use the -F option, you can hide most of the error messages that may be generated when you're using the chmod command. If you use the -V option, this is going to display diagnostic information for every file processed. If you use the -R option, the permission of files and directories will be modified recursively, which means it's going to go downward in the directory structure all the way to the bottom. The chmod command does support two different modes. We have a symbolic mode and an absolute mode. Symbolic mode enables you to set permissions using three components, which includes permission context. This can be U, G, O, or A. Now, U is user, G is group, O is other, and A applies the permissions to all three contexts, the user, the group, and the others. You can also have the permission operators, plus, minus, and equal. And you can have the permission attributes of R, W, and X, or read, write, and execute. Permission operators are going to be used to determine whether permission is granted or removed. If you're using a plus sign, this grants permissions. If you're using a minus sign, this is going to deny permissions. And if you use the equal sign, it's going to assign the permissions exactly as provided, instead of doing an addition or a subtraction of permission levels. In symbolic mode, you can use the chmod command by entering chmod, the access context, the operators, the permission attributes, and the file or directory name. The other way to use chmod is using absolute mode, and this is going to use octal or base 8 numbers to specify your permissions. Each permission, read, write, and execute, has been associated a number, and we add those up to tell us what the permission is. So if you have an octal number that has 4, that means read. If you have 2, that means write. If you have 1, that means execute. But if we add those octal numbers together, we can get different permissions and set them with a single number. This will give you the overall permission number to assign to a directory or file. For example, if I want to have full permissions so I can read, write, and execute, that's going to be a number 7, because 4 plus 2 plus 1 equals 7. When I have the read and write permissions but not execute, this will be 6, because 4 plus 2 equals 6. Complete permissions are expressed as a 3-digit number, where each digit is going to correspond to either the owner, the group, or the others. In absolute mode, the proper way to enter your command is by entering chmod, the number, and the file or directory name. Now, it's really important to know how to use octal numbers for permissions, because this is commonly tested on the exam and one that you're going to find yourself using a lot in the real world too. So, for example, if I asked you what permissions were assigned to a file that has 752 as its permissions, you need to be able to tell me what the 7 in the user position means, the 5 in the group permission, and the 2 in the other position means. So if we're going to look at that, we will say the first position is the user's, and that had a 7 because it was 752. That 7 breaks down to being read, write, and execute permissions. So the user who is assigned to this file has read, write, and execute permissions. Now if we move to the second position, we look at the group. This was a 5 because we had 752. So when we look at the 5, that means it has read and execute permissions. 4 for read, 1 for execute, and you add those together to get 5. Now, when we get to the third position, we have a 2 from 752. What does the 2 mean? Well, we know read is 4, write is 2, and 1 is execute. So if we only see a 2 there, that means the other group has the right permissions, but they can't read the file and they can't execute the file. So it would be completely fair for them to give you a question that says you have an octet assignment of 541. What level of permission does the group assigned to this file have? And then you need to figure that out. So we would say, okay, 5 means we have a 4 plus a 1 to give us 5. That is read and execute permissions. 4 is going to be for read only. So the group has read only. And 1, that's going to be execute only. So others can execute only. If you can work out problems like this on the exam, you're going to do fine on permission-related questions. The last thing I need to mention in terms of file and directory permissions is the umask command. The umask command is used to set the default permissions for newly created files and folders. This is called the umask command because it's setting up the user-defined permissions for those new files and directories. If you enter umask-S, this will display the current mask as a symbolic value. If you enter umask-P, this will display the current mask in numerical format. Now to set the umask for a file or directory, simply enter umask and the mask you want to assign, which is the numeric value of the mask you want to apply. Keep in mind, though, the difference between UMask and ChangeMod is that UMask is used to change the default permissions for all newly created files and folders, whereas ChangeMod is used to set the permissions on files and folders that already exist.